Hey, welcome to Ones and Zeros. My name is Ben, and today we're going to be taking a bit of a look at another one in our series of C++ videos. Today we're going to be taking a bit of a look at pointers and sort of what pointers are and some of the different ways that we can use them, what they're actually useful for, and hopefully shed a bit of light on them because they're things that we're going to be using in some of the C++ videos moving forward. And if you've been watching any of our STM32 videos, then you'll probably find that we've been using them a bit in different places in those videos as well. So if you've been watching some of the previous videos, you might also notice that the camera quality is a little bit better, thanks to a good friend of mine had some upgrades, so hopefully the stream quality is going to be a little bit better moving forward. But let's take a bit of a look into pointers and get a bit of an idea of what they're all about. So let's jump to this one right here. And much like a lot of the C++ videos that we've been doing previously. See if my camera wants to behave. There we go. Much like the C++ videos we've been doing previously, we're going to be looking at using Visual Studio for this one, just to help make things a little bit easier rather than having all of the extra bits and pieces required when we're working with microcontrollers. So if you have seen the video that we put out on variables, then you'll recognize certain parts of what we're going to be doing. And there'll be some stuff that we will be sort of covering a little bit again to sort of help explain what pointers are as well. So you'll probably be familiar with the fact that, say for example, we can create in this case, a global variable, which will make it an integer. And let's just call it test variable A. And we'll put the value of 10 in it. Now, that's all fairly simple and something that we've come across before. However, there's a cool little trick that we can actually do when we're dealing with variables that I'm going to sort of explain with a bit of a visualization. So we'll jump over to this screen and I'm going to have a look at the sort of diagram that I explained during the variables video, which is if you think of computer memory like it's a long street with a whole heap of different properties along the side of it. I'm losing my voice already tonight. And each of these properties has its own sort of house number. So I'm going to start with 0, 1, 2, 3, 4, 5, 6, and so on. Now, each of these can store a number, which is what we're doing when we create a variable like the test variable we just created that we pop 10 in. However, all of these addresses that we have here, so our 0 and our 1 and our 2, etc., are also just numbers. So one of the things that we can actually do in a variable is we can actually store not just a number that we might be wanting to manipulate for some mathematical purpose, but we can actually store an address to another location in memory, which is essentially what we're dealing with when we're talking about pointers. So let's have a look at how that actually translates to when we're dealing with code. So in this case, we've got our test variable A, and just so that we can get a bit of an idea of what's going on, we'll print a few things to the console so that we can see what we're doing as we go. So let's print out our test variable A, like so. which is pretty simple to start off with. If we run that, of course, it's going to come up with a message saying test variable A, and it's going to give us the value that we've actually stored in there. Now, what we can also do is we can go through and we can create a pointer to an integer, which is denoted by the fact that we've popped a star after it. So still just an int, but the star denotes that it's basically pointing to an integer rather than just being an integer on its own. And let's call this test pointer A. And we will assign that the address of our test variable A, and by using the ampersand, that allows us to actually get the address that this test variable A is being stored in, rather than just retrieving the actual value of 10 that's being stored in there. So if we might actually just copy and paste this, make life a little bit easier. And we'll rename this. Make sure everything lines up nicely just for the sake of it. And in here, we're going to get it to print what is being stored in test pointer A. Now, we're not actually going to get the value of 10 because we're going to basically ask it to tell us what the address is that's being stored in test pointer A. So again, if we run this, then we can see that while our test variable A is storing a value of 10, we're actually getting quite a different value when we take a look at test pointer A. And what this is it's actually the address in memory that our test variable A is being stored in. So much like when we look at the diagram of our street with all of our house numbers on it, the particular house number that our test variable A is being stored in is this 006DD034, which is a hexadecimal value that represents that particular address in the computer's memory where test variable A is being stored. Now, we can also use that pointer to be able to retrieve the value that it's pointing to as well. So if we let's go test pointer A value. Again, we'll line all this up just so it looks neat. And this time, rather than just doing test variable A like we have there, we basically want to tell it that we want to access the data that is in the memory location that test pointer A is actually pointing to. So we'll change this to test pointer A. And then the way we tell it that we want to access the data that's stored in that location rather than just the address itself is by popping a star prior to the name of it, which then lets the compiler know that we don't want to retrieve the address, we want to retrieve what's in that location. So again, if we run this one, then we can see that while we're still getting our address as we were before, when we're asking it what was in that address, we're actually getting the value 10 because that's the same as what we've got in our test variable A. So essentially that allows us to use a pointer to point to a location where we've got a particular bit of data stored. So that's kind of a little bit of a basic overview of some of the ways that we work with pointers. So the main things being that in order to declare a pointer, we declare what type we want to be pointing to, followed by the star after it. in order to retrieve the address of a particular variable, then we use the ampersand before the name of the variable, which then allows us to retrieve the address of where that variable is being stored. And then if we want to access the data that is stored at that location, then when we go to type in the name of our pointer, we put the star before it, which then allows us to be able to access the data at that location rather than accessing just the address like we did here. Now, there's various reasons why it can be really useful to make use of pointers in various different situations. So say, for example, let's get rid of this stuff for the moment. So we'll get rid of that, and let's create a function in here. We won't worry about it returning anything, but let's just call it add1. And we're going to pass it a pointer to an integer. So again, int with the star after it. And let's just call it p-value. So p denoting the fact that we're dealing with a pointer, just kind of allows us to sort of see what's happening there. And we'll actually pop this up above our main so that main can actually see it, as we kind of discussed a little bit during our scope video, which we did in the last video of this series. So because we're passing an actual pointer to this function rather than just a normal variable, it gives us the ability to be able to modify what that pointer is pointing to, which can allow us to do some slightly interesting things. So if we might actually make two of these functions. So we'll have add1 pointer and we'll have add1 variable, which might help us sort of explain this a little bit better. And this one, rather than taking a pointer, is just going to take an integer. So in the case of when we're passing an actual pointer to it, we can, for example, go p-value ++, for example. So we're using the star to tell it that we want to access the value that's stored at the location that's being pointed to. And we want to be able to add 1 to that value, which is why we've got the ++ after it. And say if we declare a variable down here, and we'll just call it test variable, and we'll make that 0. And then we'll call the function add1 pointer. We'll pass it the address of that test variable, so using the ampersand to be able to pass the address to that. And then let's get it to print that out. Like so. So if we run that, still actually getting a 0. Let's try doing it this way. It may not have liked the way that we've done that. Let's create a variable here and we'll call it test1, and we'll make that equal to the value that's in p-value. Then we'll increment the value there, and then copy that one over to the location being pointed to by a p-value there. See if it wants to allow us to do it that way. So we'll run that one. And there we go. So what's actually happening there is that we're starting off with a value of 0 and passing the address of that test variable to this particular function, which is then taking a copy of that, adding 1 to it, and then copying that back into the location being pointed to by a p-value, which then gives us the value 1. Now, why that can be a good thing is in the sense where, unlike a normal function where we're just passing just the variable itself, if we were to try and do the same thing here, and we'll again just call this test1, copy I value into that, go test1++, just like we did for our add1 pointer. And then if we try and go I value equals test1, we potentially going to run into an issue with that. If it wants to, might help if I actually close the one that we had running. Let's run that one. And we can see straight away that we're actually going to get a build error. So the reason for that, and actually we need to pass it just the variable and not an address to that one, so we'll get rid of the ampersand there. And we can see that this time we get a 0 rather than getting a 1. Now the reason for that is because when this function gets called, it's actually creating a copy of test variable, which is being passed into this function here. So it's creating a whole new copy of test variable with the 0 in it, which is then being popped into here, and we're adding 1 to that, and then we're trying to copy that back into our I value here, which is not allowing us to actually modify our test variable, which is why it still comes up as 0 when we run it, because we're modifying an actual copy of that rather than modifying the original value itself. Whereas when we do it with our add1 pointer, we're still creating a copy, but we're creating a copy of the address to the data where test variable is being stored, so that when we actually go to modify that, we're still actually modifying the actual data that is held within test variable, rather than trying to modify a copy of that. So allowing us to do that sort of thing can be quite useful in those sort of situations, especially if you've got say a situation where you may have a function where, say, we'll just call it test function and just put a void in there, so it's not actually receiving any data, but it's returning an int. Now, we may come across a situation where we want to be able to return more than just the int from this function. And there's certain ways we could do that. We could create like a structure as a type definition or something like that, which is something we're going to look at in a future video. But the other way we can do that is we can actually just pass some parameters like we did before, where we're actually passing in a pointer like so, and that allows us to not only return this int value from the function, but it also allows us to modify whatever this pointer is pointing to, so that we can actually manipulate multiple bits of data that can then be used by whatever bit of code is actually calling that function. So I hope that kind of makes a bit of sense. The other thing that we can use pointers for is for dynamic memory allocation as well. So let's get rid of these functions here, and we'll get rid of this stuff for the moment as well. So let's call this one test variable stack. So because of the way we have created this variable here, it's going to exist in the part of memory known as the stack. So you've typically got two different parts of memory within the computing system, whether you're dealing with a microcontroller or a normal PC or whatever. So you've got the stack and the heap. So the stack is used for situations where we're declaring variables, like there's a local variable that we've declared here, whereas the heap is typically used for when we're dynamically allocating memory. Now there's something we're going to go into a little bit more in future videos as well, but basically the trade-off is that stuff that is stored in the stack typically has less processing overhead involved in creating the variable and destroying the variable. Whereas when we go to allocate some memory in the heap, the system needs to go through and actually find a free bit of space that's got enough storage to be able to store what we want to be able to put in there. And then when it goes through to delete it, it's also got a few little tasks it's got to do to be able to clean up after that as well. So that can take a little bit of additional time when you're dealing with dynamic memory allocation like that. So a bit of an example of the difference there would be if we create an int pointer, and let's call this test variable heap. And in this case, we're going to use the new keyword, and we're just going to go new int, which is basically telling it that we want it to create a new integer, and that's going to be pointed to by this test variable heap pointer, which is a pointer because we've popped the star after the data type. So in this situation, if we wanted to put, say, the value 1 into there, just so that we can sort of see the difference between the stack and the heap version, then it's similar to what we did before in the function, where we would actually go star int to tell it that we want to access the data at the location that it's being pointed to. And we're going to pop a number 1 in there. Might actually help if I use the variable name for that one. So that'll be test variable heap equals 1. And then if we print both of those out, so we'll do our stack one first. Might help if I add the right number of colons in there. And then for this one, because we want to actually print out the value that's located at the address that test variable heap is pointing to, we need to do the star before the name. Otherwise, we're going to get the actual address that it's being stored at, like we saw before. The other difference is, in order to prevent memory leaks, because we've dynamically created this one here, we also need to make sure that we actually delete it afterwards, because the computer's not going to do that automatically for us. There is certain things called smart pointers and stuff that we can use, which we'll get into in future episodes. But for the moment, because we've created this with the new keyword, we're also going to need to use the delete keyword and tell it that we want it to delete test variable heap in order to prevent memory leaks. So again, if we run this one, we can see we've got 0, which is being stored in our test variable stack, which is being stored in the stack memory. And then we've got the number 1, which we're storing in our test variable heap, which is our dynamically allocated bit of memory that we're creating and then deleting. So that's a bit of a rough look at sort of what pointers actually are and some of the different ways that they can be used. In some of the upcoming videos where we start to look at things like arrays and structures and things like that, we are going to be using pointers more and more. They can come quite in handy in situations where, say if you have a data structure that, let's just say it's 1 kilobyte in size, it's got a whole bunch of data in it. Rather than creating a copy of that and giving that copy to some other bit of code to get it to do some processing on it, we can just actually pass it a pointer to that particular section of data, which saves us not only doubling the amount of memory that that's then using, but it also allows things to happen a lot quicker because there's a lot less CPU overhead required for us to just pass on an actual pointer to the particular data that that function or that bit of code needs to be able to access. So if there is any questions or anything like that on this sort of stuff, definitely feel free to leave a comment. There is also our subreddit, so r/ones and zeros. Feel free to leave a comment there, or our email address, so onesandzeros.contact@gmail.com, which bring those guys up on the screen for you now. Should be that one. So you can see we've got our contact details down the bottom there. If my camera wants to behave itself, there we go. So those guys down there. And if you did find this interesting, definitely would love it if you followed us on Twitch, or if you gave us a like and subscribe on YouTube. Definitely means a lot. And if there's particular topics that you'd like us to cover as far as C++ or just general questions and things like that that you've got, like I said, definitely feel free to ask or leave a bit of feedback. Curious about it all, and the goal is to try and provide stuff that's going to sort of be useful to people. So definitely appreciate any feedback there as well. So thank you very much for watching. Hope you found it interesting, and hope you have a great night or day or evening or whatever it is wherever you are in the world. Thanks for watching.